Hello. In this video I will show you how to operate the Qsep100 system. The Qsep100 is a biofragment analyzer and it's used for 1 to 96 sample runs. So you can put PCR tubes in there, 8 samples, 1 sample, 12 sample or 96 well format plate. The system comes with a cartridge box or a cartridge kit, which includes 2 cartridges. In this case, we have an S1 cartridge, which is a high resolution cartridge. And it's very simple. When you turn the instrument on, plugged in to the AC panel, turn it on, and then the cartridge, basically there is a door on top, which we call it a cartridge door. It opens up. And then you insert the cartridge in, it goes one direction with the slot, so it keyed in. Put it in the instrument, close the door, and then open up the cartridge door, the sample door. And then in the sample door area, we have a buffer tray position. So we can move the buffer tray forward to be able to put all the solutions into the buffer tray. As it's moving forward, I will take off the disposable buffer tray from the instrument and I will show you where each of the solutions provided in the kit are allocated in the buffer tray. So this is the buffer tray. Very simple. It comes in four troughs, and 3 of the troughs are basically a DI water, okay? And then we have the separation buffer, everything included inside the cartridge kit. We also have alignment markers and DNA ladder that we provide with cartridges that can be run in the instrument to calibrate the cartridge. So once you pour all the solutions into the buffer tray in all of the troughs, you transfer it inside the instrument and then also allocate your alignment marker and the DNA ladder and put it in the buffer tray position. Close the door and then you need to latch the cartridge. So when I hit the latch, you will hear this sound, and what it's doing, basically it's incorporating all of the optical, electrical, and pneumatic channels into the cartridge. So it's engaging with the instrument. And it reads, because each cartridge also comes with an RFID chip already embedded in the cartridge. And this RFID chip is being read in the instrument by a reader, which tells you what kind of a cartridge it is, how many runs have been programmed into the cartridge. For an S1 cartridge, we have about 200 runs. So it will decrement the number of runs as you're using it with your sample runs. And then each cartridge has an electrode on top, electrode on the bottom, and the capillary is running along the leg, and the buffer reservoir is on the top. So all of the gel metrics is sitting right here, and every time in the instrument it gets purged from the top, so a fresh gel goes into the capillary, and then the samples are injected electrokinetically by applied voltage in between the 2 electrodes. And then it goes into the buffer tray, and then we do the separation, and then the fragments are separated and migrating toward the detection zone, and we detect somewhere in the middle of the cartridge. So basically the sample, as they get injected, they get tagged by the fluorophore as part of the gel metrics in the capillary, and we detect the fluorophore with our fluorescence reader in the instrument. So I'll show you in the instrument when you latch, and then you're ready to do the calibration, and you will see the steps that it's going to go through. I'm going to select the calibration mode and then hit the run. And when it starts, basically it's doing the homing position in the instrument, and it's going to go and park right underneath the cartridge, and it's going to do the purging, cleaning, washing of the capillary tip, and introducing a fresh gel from the top reservoir into the capillary, about 60 seconds. And then it will go through the process and it'll give you results in 2 to 3 minutes. Thank you. So here I will show you how to run the Qsep100 system, the biofragment analyzer, using the pen-shaped gel cartridges. So when we insert the gel cartridge, in our case is an S1 cartridge, we do a latch to engage all the pneumatic, electrical, and optical connections to the cartridge to be able to communicate. Also, as I mentioned before, the cartridge has an RFID chip and it's being read by the instrument, so we know the information. It's an S1 cartridge. It has 187 runs left in the cartridge. Originally had 200 runs and has a expiration date of October 3. So this cartridge is good to go. Next, to run the cartridge, I'm going to use a DNA ladder that we provide. So to run it, you basically choose your sample position, and in my case I have chosen the MA2 right next to the alignment marker, which is in the buffer tray position, and then we say OK, and I'm going to run this cartridge with a method of 8 kV 200 seconds for the S1 cartridge, which will be a little bit faster. Resolution will be reduced compared to the 6 kV 300, but you will get an idea as far as the 4 base pair resolution at a designated portion of the fragments. And then you also name it. In my case, I like to choose the cartridge number, and I'm going to call this ladder 1, and then hit the run. So as we are running, the instrument is going to basically go through the motions of purging, and you can see right now it's being parked. So in the bottom of the software, the Bioptic software, we show a park position, which is going to be purged for 60 seconds, and it's decrementing. You can see the 60-second right here. And what we are checking here is during the run, we want to make sure the current is steady. The gray line here is showing a very steady current. Right now, we are monitoring the baseline, and the baseline is it's going to be all over. The red color one is going to be all over because it's in relative fluorescence unit, and once the peak shows up, then everything is going to be normalized. So, and the other thing that we pay attention is the total counts. So this is the raw counts in the bottom. You can see 11,500 counts is being detected with the PMT detector. So after 60 seconds of purging, or high voltage purging, which is basically cleaning the capillary, the instrument will change the position of the buffer tray to a wash buffer. You can see here again it shows wash buffer, and basically is doing a dip of the capillary tip, and then the next one is again also a water dip to do the cleaning. And then once it does the cleaning, which is 2 steps, and we are doing all of this to make sure there are no carryovers, then it goes to MA1 position, which is basically the alignment marker, as I explained before, as the lower and upper marker. In this case, we're using a 20 base pair lower marker and a 1000 base pair upper marker. So we just injected the MA1 10 seconds, and then now we are going to the position tool, which is the sample, or actually our DNA ladder positioned at MA2, and we inject that for 10 seconds as well. And then the next step is, of course, it goes into the buffer position to do the separation. And in a few seconds, you will see the start of the run, showing the actual baseline, and we also display the current in gray color. So we are showing here the actual baseline in red, and the actual current, which is important. We need to have a very steady current to make sure everything has been injected properly and the cartridge is functioning properly. So current is a good diagnostic to say everything is working fine. We don't pay too much attention to the baseline noise right now, this peak-to-peak noise that we are seeing right now, because it's magnified, it's zoomed in. The software has zoomed in, but once the first peak comes out, which is going to be around a little bit over 1 minute, we will see the first peak, which is the 20 base pair, a lower marker, and followed by the DNA ladder peaks. And then hopefully within 3 minutes, the whole thing is going to end. And in the bottom, we are also showing the gel image. So pay attention right now. The first peak came out. So the first peak again is the 20 base pair, followed by multiple peaks for the DNA ladder, which is the PBR322. So once all the peaks come out, and then software automatically will designate a size for each of the peaks according to the DNA, to the reference marker that has been generated previously in the factory. And then you will see the end of the results in about 2.5 minutes. So we got a few more peaks to go here. And you can see a very strong signal. And we are showing a relative fluorescence unit here on, and then for the time, you can see on the x-axis we are showing the time, which is in minutes. And we also display the seconds. Here you can see 35 microamps of current and about 35 more seconds left. So already all of the peaks came out, and very soon the whole run will end. And then each peak will have its designated size on top of it. So again, steady current is very important. The gray line is showing the steady current. Once the run is over, then we will remove the current just to show you the electrophotogram. So here is the actual run. And you can see the lower marker 20 and upper marker 1000. And then if we zoom in this area, you can see a good resolution for about a 4, 5, 6 base pair resolution, and the rest of it, and the overall size is baseline noise is also very clean. And we also display the peaks, individual peaks with the peak area, the actual calculated concentration for